All right, welcome back. This is section 10.8's discussion on nonlinear systems of equations. So the very first one that we want to talk about is number one. It has a graph, it has a system, but it also has that system graphed out, and it asks you to find those 2 points. And they're right here. They're where the 2 graphs intersect. I kind of just rudimentarily drawn this. So the first point here is at -2, 2, so that would actually just be your point, -2, 2. And then the right one here is at 4, 8. So it's literally just asking you to find where those 2 lines, the blue line, the red line in the homework, not here obviously, but where those 2 lines intersect. And that's there and there, and you just have to pick out the points, right? So that's number one. Let's take a look at number 2, that was asked. 2 says use any method to find all solutions of the system of equations. Enter your solutions as ordered pairs with no spaces. We're given this system, y equals x squared. And y equals x plus 30. Okay. And knowing what this looks like graphically can help you determine how many solutions that you're looking for. I know that y equals x squared is just that parabola like we had in the last one. And then y equals x plus 30 is just a straight line that goes through wherever 30 is. But you can see we're going to have 2 solutions, right? My graph is terrible. There's no way in hell we're going to figure out what this point is and what that point is by this graph. So let's do it by substitution. I know that y is equal to x squared, and therefore if I take that x squared and replace the y in the other equation, I should get x squared equals x plus 30. This is just a quadratic in x. And so I'm going to subtract x and subtract 30 to give me x squared minus x minus 30 is equal to 0. I do that so that I can factor this as x minus 6 times x plus 5. Right? Equals 0. And you can see that we'll get x equals a positive 6 or a negative 5. Right? So graphically, I erased it, but that tells you where those x values are, over to the left, over to the right. All I have to do then is just plug this in to figure out where my y value is. If x is negative 5, y is negative 5 squared, which is 25. And if x is 6, y is x squared, so I get 6 comma 36. And those are my 2 points. Good. And I know that's all of them because graphically I only had 2 that showed up. All right, let's look at number 7. Which says find all the systems to the solutions to the system. And I've got x squared plus y squared equals 10. And x minus 3y equals negative 10. So this top one is the equation of a circle, x squared plus y squared equals r squared. So it's a circle with radius of whatever the square root of 10 is, 3.2 or something like that. And the other one is just a line. There's first degree x, first degree y, so it's just a line. So we have a couple of different options here. Is my first one, that circle, my line could completely miss it, and there could be no solutions. Or my line could come and just barely touch it and then leave, and therefore there's one solution. Or I could go through it at some 2 points and have 2 solutions, right? So at most, we're looking for 2 solutions here. But it's possible it could only be 1. And it's also possible it could be 0, right? But I'm going to plug in a substitution, right? I can solve this bottom equation 4x by simply adding 3y to both sides. And since x is equivalent to 3y minus 10, I can take this, plug it into my x upstairs, so I have 3y minus 10 squared in place of my x squared, plus y squared is equal to 10. I'm going to square this 3y minus 10, that's 3y minus 10 times 3y minus 10. You'll find that you'll get a 9y squared minus 60y, and then plus 100. Right. Plus y squared equals 10, and I have a quadratic in y, right? Simplify this a little bit more, I've got 10y squared, and I've got minus 60y. I've got this plus 100, but I'm going to subtract this 10 over to this side, so that gives me plus 90. And they may be big numbers, but I can divide everything in here by 10. So I'm going to, and that gives me y squared minus 6y plus 9 equals 0 still. And that's not bad. That factors to x minus 3, y minus 3 times y minus 3. And so this is how I know that I only have one solution, is because this factor is the same as that factor. This just gives me y equals 3. If I had two values, and it still possibly could be two values, but if I have two values, they both happen at y equals 3, right? So if I plug this in here though, on this line, there's only one place where y is going to equal 3, and so I know I only have one solution, right? So I'll plug it in here, y is 3, then x minus 3 times y, which is 3, should equal negative 10. That is, x minus 9 should equal negative 10, and if I add 9 to both sides, then I have x equals negative 1. And so that's my final solution. X is negative 1, y is 3, it's the only one, so it was that case 2 where it just comes and touches it and doesn't go through the circle. That's it for this one, so hopefully that was helpful, and I'll see you guys for the next one.